two new vector network analyzers, one compact and one full size. Both go all the way up to 26.5 GHz. Today, we're unboxing RIGOL DNA5000 and DNA6000. In 5 minutes, I will show you what's in the box, the differences between the two models, the main ports and features, and a quick e-calibration walkthrough to get you set up fast, without the heavy theory. Let's open them up. Here's everything included: the instrument itself, the USB cable, and the power cord. And if you order calibration options, it may ship separately in a case, like the electronic calibration module. Now, a quick comparison. The DNA5000 is the more compact mobile option. It's designed for field work and flexible bench use. It's easy to take from bench to bench or out into the field, while still delivering a lab-grade performance. And the DNA6000 is designed more as a high-performance test platform for R&D and automated production. With a larger chassis, it's better suited for complex device characterizations, multi-port measurements, and high reliability test workflow. Both models cover frequencies up to 26.5 GHz, so either one should be ready for serious RF and microwave work. The key difference is port count. The DNA5000 is a 2-port analyzer, while the DNA6000 is available in 2-port and 4-port versions. That means more flexibility for multi-port devices, more complex testing, and fewer reconnects. Now, let's take a look at the back. On both units, you will find key interfaces for bench integration. LAN for remote control, USB for data transfer and accessories, and HDMI if you want to connect to a larger display. On the DNA5000, you can find some mounting holes here, which makes it easier to place on a workstation. On the DNA6000, you get an additional interface, a GPIB port, which gives you another way to connect to this device. Now, let's power them on. Once it's powered on, the first thing I check is how quickly I can move through the UI. So in the response area, you can quickly change measurement settings. You can switch display formats, like log magnitude or Smith chart. You can also adjust IF bandwidth. Then just below that, you can move into the frequency and sweep related settings. So before any real measurements, calibration is one of the most important steps on vector network analyzer, because it makes your results more trustworthy by moving the reference plane to where your device is actually connected. On these VNAs, you will see two calibration options: the basic calibration, or ECal, and the electronic calibration, ECal. Today, I'm going to walk through ECal. The first thing to do is connect the ECal module with the USB-C cable. ECal usually needs a preheat period. That's about 10 minutes. And once that's done, the status light will turn from red to green to show it's ready. While that's warming up, there are a few things to set before calibration: frequency range, sweep points, sweep type, and IF bandwidth. For frequency range, match it to the device you are testing. For example, if you're working with a 3 GHz low-pass filter, you can set it from 10 MHz to 5 GHz. For sweep points, a common choice is 1001 points for a good balance between resolution and speed. For IF bandwidth, smaller gives you more accuracy, but also means a slower sweep here. Let's set it 10 kHz here. One important rule: if you calibrate and then change those settings afterward, you will need to recalibrate. Otherwise, your results won't match the current setup. Now, the light turns green, which means the preheat is ready. And let's connect the SMA cable to the port. And then connect the cable to the ECal. Now, let's press Cal button. And then choose ECal. And then follow the on-screen prompts. Next, click Measure. See, the E-calibration is done now. So from here, you start to see what this DNA is really built for. You can view results in different formats, like log magnitude, linear magnitude, or Smith chart, depending on what you're looking for, and enter math function. You've also got tools like DTF and time gating, so it goes beyond just basic S-parameter measurement. And that makes it a useful tool for applications like passive device testing, impedance test, high-speed interconnect work, or even material testing. That's the DNA5000 and DNA6000, unboxed, powered on, and calibrated.
Silent for unique electronics.